All grade 12 learners in Limpopo, Kagiso Trust has partnered with the Limpopo Department of Education to bring you radio lessons live on Capricorn FM to limit the impact of lockdown during the school calendar. So today we're doing mathematics. Klasini ndo joinwa nga marubini ndi machiruni.
Machiruni abudinga manda.
Barimini.
Ando takala chote.
Keso marubini ke babodana baba namba bathomisa na pfunzo.
Today is the 30th of May 2020. Welcome Capricorn FM listeners. Welcome Matric class of 2020. It is mathematics lesson brought to you by Capricorn FM, Department of Education Limpopo, and Kagiso Trust. Today's topic is compound and double angles. Remember, the main topic on this one is trigonometry. In other words, this compound and double angles is grade 12 work. In grade 12, we only talk about the double and the compound angles. Remember, for every topic that we are learning, you must make it a point that you are advised by examination guideline together with CAP's document. Marks allocation in trigonometry is plus or minus 40. Like other topics, work is continuous from the previous grades. For you to do well in trigonometry, you need the basics of trigonometry, and that is basically the work that you have learned in grade 10 and also grade 11. I want to walk through exam questions in trigonometry. These are the main aspects of this chapter that you need to study for you to do well in trigonometry. I hope you know that examiner may not include everything that you have learned from the book. However, examiner will try his or her best to set all the main aspects of each section. So I'm going to walk through exam with you here. In other words, I'm trying to get those aspects that are very, very important when you are working with trigonometry. It is advisable that you need to have a pen and also a book to write on, so that some of the things here, you are going to write them down so that it is easy for you to revise when you'll be practicing on your own. The first part that I want to discuss with you in trigonometry, that is reductions. You have done reductions in grade 10 and also grade 11. In grade 11, I think you've done a lot of them, reductions. And again, I've separated them to have two parts, this type of reductions. The first part is whereby you are not given angles. Angles are given in terms of the unknown. For example, theta, x, or a. In most instances, we end up using theta or x. The first part of reduction is when you are given that sine 180 plus theta, sine 180 degrees plus theta. You need to ask yourself, in which quadrant do we find this 180 degrees plus theta? It is in the third quadrant. Then if you check, in the third quadrant, sine is negative. When you do reductions, then you write it as minus sine theta. Minus sine theta. Still in the same work, let me give you this other illustration. If I give you cos, open bracket, theta minus 90, theta minus 90. don't get confused. It is not 90 minus theta, but in this one, it is theta minus 90. Where do we find this one? We find this one in the fourth quadrant. And again, in the fourth quadrant, you know that the value of cos is positive. It means we are going to get a positive answer. Since we have 90 degrees, we cannot maintain this cos. It means our answer should be given as sin theta. I was trying to explain simple thing to say reduction in terms of the unknown angles. In other words, that was sin 180 plus theta, cos theta minus 90. So I hope you know many of them. You might have seen them, you have already done them in grade 11. Still, in reductions, there's another type of reductions that one can do where the angles are known. For example, if you are given tan 225 degrees, tan 225 degrees, the first question that you need to ask yourself is to say, 225 degrees, in which quadrant do I find it? And you can immediately notice this. It is in the third quadrant. Then you go further. How can I express the angle that I find in the third quadrant? How to express the angle that I find in the third quadrant? You say 180 plus theta. 180 plus theta. So, since we've got 225 degrees, we are going to say it is tan 180 plus 45. Tan 180 plus 45. It's in the third quadrant. In the third quadrant, we know that the value of tan is positive. Therefore, we end up writing tan 45. And I hope you know that tan 45 is equals to 1. Let me also give you the second example, still in reductions in terms of the angles. I'm going to give you sin 135 degrees. If we check, 135 degrees is between 90 degrees and 180 degrees. 135 degrees is between 90 degrees and 180 degrees. Therefore, what are you going to do here? How do you express the angle in the second quadrant? When you express the angle in the second quadrant, it should be 180 minus theta. When you express the angle in the second quadrant, it should be 180 minus theta. Since we want to express 135, I'm going to say sine, open bracket, 180 degrees minus 45 degrees. 180 minus 45, which indicates that indeed it is in the second quadrant. Then you ask yourself, is sine positive or negative in the second quadrant? Of course, sine, it is positive in the second quadrant. Sine is positive in the second quadrant. Therefore, when we simplify it, we'll get sine 45 degrees. Sine 45 degrees. If you try to use a sketch there, you would find that sine 45 degrees is equals to what? 1 over root 2, or you write root 2 over 2 when you express this with a rational denominator. Remember, we have only done number one. Number one, we were trying to express reductions in terms of the unknown angles and also in terms of the known angles. Number two, you also have to learn about general solutions. Remember, it's simple application of factorizations that we have learned, especially in grade 10. Here in general solutions, there will be binomial expressions, trinomial, just like that, and I hope you'll be able to know how to factorize that. If you are struggling with factorizations, grade 10 work, I can tell you that you may not do well in this question since we need factorizations. You still have time. Let me advise you that go and make it a point that you revise factorizations, the work in grade 10. When we talk about these general solutions, I hope you know the period of cos and sine, and that is 360 degrees. But period of tan is 180 degrees. But one may ask a question. Why do we talk about period? We are saying, how long will the graph repeat itself? How long will the graph repeat itself? In other words, for 10 graph, in order for the graph of 10 to repeat itself, it takes only 180 degrees. But in cos and sine, they take 360 degrees. In general solution, let me just give you one example of these general solutions. I'm going to give you 3 sine theta is equal to cos theta. 3 sine theta is equals to cos theta. If you check on this one, we've got sine and cos on the other side. We are disturbed because on the left-hand side of the sine there is 3. Therefore, we may not change angles. What are we going to do? We better change cos and sine so that we can remain with one trig ratio. We better change sine and cos so that we can remain with one trig ratio. Since the angles are the same, we've got sine theta. It's only theta, cos theta. So the angles are the same. Therefore, we rather change this one to have one trig ratio. What are we going to do here? We are going to divide each side by cos. We are dividing each side by cos. Why do we divide by cos? Because we know that if you divide sine theta by cos theta, it is going to give you tan theta. Sine theta over cos theta is going to give you tan theta. Therefore, we will have 3 tan theta is equals to 1. 3 tan theta is equals to 1. Then you divide by 3, you remain with tan theta is equals to 1 over 3. Tan theta is equals to 1 over 3. I hope you can be able to continue with this one. Can I remind you now? The first one was reductions, 2 types, with unknown angle and known angle. Number 2, it's general solutions. These are the main sections that you have to learn in trigonometry. Number 3, you will be requested to prove identities. And this is the type of work that you have also done in grade 11. Let me just give you one illustration here. I am giving you are showing by division sign. On top of the numerator, you write the following. It is 2 tan theta minus sine 2 theta. 2 tan theta minus sine 2 theta. The whole of that you divide it by 2 sine squared theta. 2 sine squared theta. In other words, in the place of the numerator, you are supposed to write 2 tan theta minus sine 2 theta. In the place of the denominator, you are writing 2 sine squared theta. 2 sine squared theta. But the whole of those things that I've mentioned is equals to tan theta. It is equals to tan theta. So what are you supposed to do here? You are supposed to prove that left-hand side is equals to the right-hand side. Left-hand side is equals to the right-hand side. So make it a point. I hope you remember that one very well. I'm just highlighting for now. Later, I'm going to go deeper. Then, again, in number 2, we may simply just give you the following thing. We may just give you cos 70 plus cos 50. And then you can be able to calculate to check exactly what value will it give. Then, that is number 3. Number 3, you must learn to prove identities. You must learn to prove identities. If you take any grade 12 textbook, you will see more problems. Then you just go there and practice. You get them right. Number 4, I have also learned from the question paper that sometimes they ask you to expand the compound and the double angles. Sometimes they request you to expand the compound and also the double angles. For example, you can be given cos, open bracket, a plus b, close bracket, is equals to, you have to express that. It's a simple stuff. Something very interesting in this question. You would also find that you also have this in a formula sheet in examination. The only thing that you have to do is just to copy and write it in your answer book. They give you marks for that. That's why your sin is so unforgivable if you get 0 in mathematics. Because sometimes you'll have to take formula from the formula sheet that you have. You write it in your answer book. You get marks for that. So you are supposed to expand cos A plus B. Cos A plus B. And it's easier. You know that is cos A, cos B, minus sin A, sin B. Then you know how to expand that one. Or else, you can also be given sine of A minus B. Sine of A minus B. In other words, it's sine, open bracket, A minus B, close bracket. Then you have to expand this. And you know that it is sine A, cos B, cos A, sin B. And in the middle, the sign should be negative. The sign should be negative. If it is A minus B, the sign there should be negative. So in other words, you must know how to expand this one. If indeed you are struggling with this thing, you need to make it a point. You either create a song, you memorize, so that it can be easier for you to work out on these problems. So number 4, you will be expected just to expand compound or double angles. That is number 4. Then when we come to number 5, you are supposed to learn about sketches. You are supposed to learn about sketches. For example, if you are given that sin 13 degrees is equals to P, they say, find the following in terms of P. Find the following in terms of P. If you are given this, you know that sin 13 is the same as, is equal to P over 1. Then you draw that in the first quadrant. One may ask a question, why do we draw in the first quadrant? Oh, we've got 13 degrees. 13 degrees between 0 and 90. It tells us that it is found in the first quadrant. Then you are going to draw there. In that diagram, you make it a point that you also get the unknown side by using Pythagoras theorem. If you are given sin 13 is equals to P or any other letter, it could be sin 31, it could be sin 29, it could be sin 18 or tan cos, depending on what examiner wants. So, if you are given this one, you are going to draw a diagram taking into consideration that 13, it is found in the first quadrant. Then you can be asked to determine tan 13 degrees, cos 13 degrees. I hope you know that one. Remember, it's number 5. We are talking about sketches. But besides this type of a sketch, we also have the second one, whereby examiner may give you two ratios. Examiner may give you two ratios where there will be probably added information so that you can be able to draw your sketch in appropriate quadrant rather. Then, if you are given that sine alpha is equal to minus 3 over 5, sine alpha is equals to minus 3 over 5. If we check properly, here sine is negative. And again, we are given that this should be found from 0 up to 270 degrees. This simply indicates that we must choose any quadrant from number 1, 2, and 3. And the place where sine is negative. Of course, if I ask you a question, in the first quadrant, is sine negative? No, it is positive. In the second quadrant, is sine positive? Yes, it is positive. In the third quadrant, is sine negative? Yes, it's negative. Therefore, we are supposed to draw this sine alpha is equals to minus 3 over 5 because it was indicated that alpha is the element of 0 up to 270. It means we cannot use the fourth quadrant. In the fourth quadrant, we know that sine is negative. However, that fourth quadrant, it is not included. Then, you are also given another information here. You are also given cos beta. Cos beta is equals to 5 over 13. Cos beta is equals to 5 over 13. Where they gave you extra information, sin beta is less than 0. Sin beta is less than 0. When we say sin beta is less than 0, I hope you know that we are saying sine is negative. In mathematics, we don't say sine is negative, but we say sine is less than 0. It indicates that indeed is negative. Therefore, if we check cos beta is equals to 5 over 12, and 5 over 12 is positive, it means we should be able to draw the place where cos is positive. But in that place, sine should be negative. Sine should be negative. Then you must check. If you check, where do we find cos to be positive? We find it in the first quadrant. Will there sine be negative? No. But where again can we find cos to be positive? It is in the fourth quadrant. Will sine beta be negative? Yes, it will be negative. In other words, this one, you have to draw it in the fourth quadrant. Let me repeat about number 5. Number 5, I was referring to sketches. Number 1, they may tell you sine of a certain angle is equal to P or T. Normally we use P and T and K, just that. So, and then you express everything in terms of P or T. In the second one, probably you may be given 2 angles where there will be added information that may give you direction where to draw your sketch. Number 6. Number 6, you are supposed to learn what we call trigonometrical functions. Trig functions. Or in the simple language, you can say trig graphs. Trig graphs. So you are supposed to learn how to draw graphs and how the transformation in graphs will take place when probably you reflect about x-axis or you reflect about y-axis. It goes like that. So let me just give you some simple trig graphs that you can draw. Number 1, you can be requested to draw tan x. Tan x. X is an unknown angle. They may not leave it vague like this. They will also tell you the domain that is covering. They may say it starts from negative 180 up to positive 180. So they won't leave it open like this. They will give you the domain where it is supposed to end. Then, number 2, you can also be given cos graph. For example, you can be given cos 2x. And if you check, well, cos 2x is what? It's a double angle. So if you check this one, you can be able to draw this one. You can either use points form, and you need also to follow the domain of this graph as indicated in the question. As examiner may not leave it vague like this. The third one, it could be sine. Here I've just given illustration of saying minus and half x. Minus and half x. In other words, you can be able to draw this. That is number 6. The last part in trigonometry, it is height and distance. It's height and distance. So there are some informations that you need to use, especially those that you have learned in the previous grades, especially grade 11. In height and distance, you will sometimes be requested to use what we call sine rule. Sine rule. Number 2, you can also be expected to use cosine rule. You can also be expected to use cosine rule. Number 3, you are supposed to use trig ratios. When I refer to trig ratio, I'm referring to sine theta, cos theta, tan theta. It cos, sine, tan. So all those 3 ratios. So remember, when we use all these ratios, it's when we've got a triangle whereby we know that one of the angle is 90 degrees. In other words, we use them in a right-angled triangle, in a right-angled triangle, or in a triangle with 90 degrees. But when we do not have 90 degrees, we use sine rule, cosine rule, area rule. We use sine rule, cosine rule, area rule. So these 3, we use them when we know that in a triangle there is no 90 degrees. But when there is 90 degrees, what are we going to use? We are going to use trig ratios, and together with what? Theorem of Pythagoras. We are going to use the theorem of Pythagoras. Before I can be able to go in detail, let me just give a summary of the main things that you need to highlight. I would request that each one of you need to make it a point that you write all these points, because they are going to assist you when you'll be preparing for your exam. Number 1, it is reduction. 180 plus theta, theta minus 180, where the angle is unknown. The second one is tan 225, where the angle is known. You express in that particular quadrant. Number 2, you are supposed to learn about general solutions, knowingly that we've got binomial, trinomial, just like that, and also needs the factorization skills that you have learned in grade 10. Number 3, you must also learn how to prove identities, where you are supposed to prove that left-hand side is equals to right-hand side. Left-hand side is equals to right-hand side. Number 4, you must also learn how to expand using compound and also double angles. You must also learn how to expand using compound and also double angles. Number 5, sometimes you'll be requested to solve when you are supposed to draw a sketch first. The example that I cited, it's sine 13 degrees is equals to P. And where you are supposed to determine the following in terms of P. It could be tan 13 or cos 13. Number 2, still under sketches. It's when you are given two angles. You are given two angles, you are going to draw two separate sketches for you to answer that follows. Like the one that I said, sine alpha is equals to minus 3 over 5, where alpha is an element of 0 up to 270. And the second one where you are given that cos beta is equals to 5 over 13, where sine beta is less than 0 or is negative. Number 6, I spoke about trigonometrical graphs or trig functions. So you make it a point that you go there and revise those trig functions, how to draw them, and how can you transform them when you reflect or when you translate them. Number 7, it is height and distance. And I hope you still remember that you are supposed to use sine rule, cosine rule, trig ratio, area rule, and also theorem of Pythagoras. Here in grade 12, we are doing what we call compound and double angles. Here we are talking about two things. Number 1, it's a compound. Number 2, it's a double angle. Compound and double angle. Firstly, we need to understand terminology of compound. We need to understand the terminology. Compound angles involve the trigonometrical ratio of the sum or difference of two angles. Compound angles involve the trigonometric ratio of the sum or the difference of two angles. So I'm going to continue later.
Nikolibonga manda bamarubini. Bakuntakadza ngamanda bachiri alpha. Tizino alpha ndizina langa. Yesu ndikozokopa alpha. Look at the smile.
Thank you.
But hey, we're going to take a commercial break. Keep it locked right here to the Saturday breakfast.
At Nesta, we pride ourselves in quality fast foods at the cheapest prices in Limpopo. Get 3 Viennas and chips at $11.99, beef or chicken burger and chips at $12.99, or 1 chicken drumstick and 1 wing with pop at $19.99. Treat yourself to a delicious ice cream cone at 3 Rand and an ice cream cup at 5 Rand. Branches in Polokwane, Mukopane, Tabazimbi, Witbank, and Tanin. Nesta Fast Foods. It's good. It's better. It's Nesta.
Capricorn FM urges you to take necessary precautions to avoid being infected by COVID-19. Wash your hands thoroughly with soap. Practice good personal hygiene. Cover your mouth with a tissue or your elbow when coughing or sneezing. Don't share food and utensils. Always use clean utensils and see a doctor if you are unwell. Visit sacoronavirus.co.za for more details. Kula Mahashi. Listen to Capricorn FM on 98.0.
The Saturday Breakfast, 6 to 10 a.m. on Capricorn FM. Craziness is us.
It's 20 minutes just before 10 o'clock in the morning. You're still listening to Capricorn FM, Limpopo's hardest frequency, the pioneers of progress. This is the Saturday Breakfast with Vusi Alpha. And remember, all matrix, tell them to tune into the radio right now because Kagiso Trust has partnered with the Limpopo Department of Education to bring your radio lesson to you live on Capricorn FM to limit the impact of lockdown during the school calendar. And right now we are continuing and we are doing mathematics, and I'm so enjoying hearing the alpha.
Okay. Compound angles involve the trigonometric ratio of the sum or difference of two angles. When we talk about compound, we are referring to the angle which is not original. It's just an angle that has been formed by either adding or subtracting two angles. For example, I'm giving you cos A minus B. In other words, we've subtracted B from A. The angle that now is formed, it is called a compound angle. But that is not the only way. That's why we say the angle that is formed when you subtract. Or, number two, if you've got two angles, that is A and B, if I give you sum of A plus B, we are adding two angles. The angle that is formed now, it is also a compound. So let me summarize. How can one understand compound? Compound is an angle which is not original. You can either get a compound when you subtract one angle from another. Then the angle that has remained, we call it a compound angle. Number two, if you add one angle to another angle, so the answer that we get, we call it a compound angle. So that's why we said compound. Then one may ask me a question, what is a double? Double, it means we are adding two angles that are of the same. In other words, equal angles. For example, if I'm adding A plus A, it will give me 2A. If I start with cos, I say cos 2A. We say it's a double angle. In other words, A has been doubled. So that's why we say it's a double angle. That's why we say compound and the double angles. So compound, you either add two angles or subtract one angle from another. Then we call it a compound angle. The proof is not necessary for examination if one wants to prove how to get this formula. May I advise you to go through the textbook and learn how to prove the compound formulas. The following things may be needed when you are supposed to prove the formula. Number one, you need to understand that we need to do this one in what we call a unit cycle. And a unit cycle, we are referring to a cycle where the radius is always 1. Where the radius is always 1. Number two, you need also to use what we call distance formula. And you have learned distance formula in grade 10. Number three, you need also to construct triangles. You need to construct triangles so that you can be able to work on a triangle. You have already learned almost everything in trigonometry in grade 11. The difference between grade 11 and grade 12 work is the fusion in of compound and the double angles. So, if you check the difference, you have done sketches in grade 11. You have proved identities in grade 11. You have done general solutions in grade 11. We are still going to do the same work in grade 12. The only difference is that when we'll be working in grade 12 work, we will also give some angles which are compound and the other ones which are doubled. Let me just give you a simple example that you will be able to understand here. Let me give you one identity that you get from grade 11. It is given like this. I hope you will write this one down. It is tan x plus cos x over sin x. Let me repeat. It's still on the left-hand side, remember? I'm just on the left-hand side. It is tan x plus cos x over sin x. Then tan x plus cos x over sin x is equal to 1 over sin x cos x. 1 over sin x cos x. If we check here, we do not have a double angle. So if we do not have a double angle, it means this is the identity that we have learned in grade 11. Since in grade 12, we will also put in the double and also the compound angle. On this one, it is purely grade 11 work. Then, let me give you one example that you can learn in grade 12. The first one is a fraction. We've got two fractions here. You are given sin 3x over sin x minus cos 3x over cos x is equals to 2. Let me repeat, and I hope you are writing this one. It is sin 3x over sin x minus cos 3x over cos x is equals to 2. In this question, they are compound angles. Namely, if we check sin 3x, it's not a single angle, this one. So it's a compound one. Cos 3x, this one is also a compound. So you can be able to identify that. I hope you can see the difference. We are doing the same trick that we have learned in grade 11. The only difference, we are also adding compound and also double angles. If you have tried to prove, I hope you know by now that we've got the way how to expand cos compound of cos. Let's check the first one. You are given cos A plus B. You know that it is cos A cos B minus sin A sin B. And this one, I hope, since you can find them in different textbooks, I hope you allow me just to tell you very fast. The second one is cos A minus B. It is cos A cos B plus sin A sin B. And we've got double angles. Cos 2B is double angle. There are three ways of which one can be able to express this cos, which is double angle. One, you can express it in terms of sine and cos, where it will give you cos squared beta minus sine squared beta. Cos squared beta minus sine squared beta. Number two, you can also express cos 2 beta in terms of cos, where it will give you 2 cos squared beta minus 1. 2 cos squared beta minus 1. Number three, you can still express cos 2 beta in terms of sine. It will give you 1 minus 2 sine squared beta. 1 minus 2 sine squared beta. I think this one is trying to be easier because you can get them in any textbook, even in examination in the diagram sheet. Then the other aspect here is sine, compound, and also the double angle of a sine. Number one, it is sine A plus B. When one needs to expand this one, it becomes sine A cos B, cos A sin B. Then the other one where we are subtracting, it will be sine A minus B. Sine A minus B. It will give you sine A cos B minus cos A sin B. Then the double angle of sine, it doesn't have any other option. We only have to write 2 sin beta cos beta. 2 sin beta cos beta. So it doesn't have any other option. It's only in the double angle of a cos whereby we can express it in three ways, where we express in terms of cos and sine, we express it in terms of cos only, we can also express it in terms of sine only. It is almost impossible to teach everything in just an hour. However, I am going to walk through exam questions. I am going to take each part at random. Let me start with the first part, which we call it identities. I was simply just working through there. Now we need to do them in detail. When working with identities, we will usually be required to prove one side it is equal to another. In the process, we work with the left-hand side, of which one can say LHS, independently from the other side. And also in the other side, which is the right-hand side, you call it RHS. As a general rule, we take a side which is more harder or which is more difficult than the other one. So make it a point that you pick up the side that is more difficult than the other side. And when you will be working here, you have to know your algebraic manipulations very well. You should be able to have a skill how to manipulate. Allow me just to give you some skills that you need to develop for you to work with identities. Number one, you need to change everything to become sine and cos. Change everything to become sine and cos. For example, if you are given tan x, you must know how to express tan x in terms of sine and cos. In other words, the answer will give you to become sine x over cos x. Sine x over cos x. Number two, when you will be adding fractions using the LCM method, or when you multiply, you will be able to modify it in such a way that it will also be equal to the other side. Whenever you see fractions, you must add them probably using what we call the LCM method. Look to see if we can use the compound and also the double angle. Because sometimes if you check properly, you may also find a side where there will be a double angle and also a side which is with a single angle. It is advisable to start with a side with a double angle. You start with a side with a double angle so that you can manipulate it and simplify it so that you can look with the simpler side. Then let me just give you illustration here. You write a division sign here. On top you write this one. You write sine 2x plus cos 2x plus 1. You divide by sine x plus cos x. Divide by sine x plus cos x is equal to 2 cos x. 2 cos x. So on the right-hand side, we only have 2 cos x. On the left-hand side, in the place of the numerator, we have sine 2x plus cos 2x plus 1 over sine x plus cos x. If we check well, we've got double angles there. May you please change sine 2x. We don't have any other option. We can only do it. It's 2 sine x cos x. In the other one, we are going to express in terms of cos. It will give you 2 cos squared x minus 1. When you simplify it together, you are going to get the common factor of 2 cos x. Then you cancel, you'll end up with the answer. That is proving of identities. Then we need to move on to general solutions. In grade 11, you would have a lot of practice of solving trig equations. Sometimes you have been given to a problem where you are supposed to solve quadratic equations which required factorization and resulted into 2 or more solutions. You would have also given a solution for specific intervals as well as general solutions. So, when you do general solutions, you must make it a point that you know how to factorize. Let me just give you one. I am giving you 2 sine squared x plus 3 sine x minus 2 is equal to 0. Then you are supposed to factorize. You are supposed to factorize here The first factor, it should be open bracket 2 sin x minus 1 close bracket, and the other factor, it is sin x plus 2 close bracket is equals to 0. Then when you solve the here, you will have sin x is equals to half. Sin x is equals to half. Then the last part, it will be sin x is equals to minus 2, of which we will not have a solution. Make it a point that you reverse everything, so I can't be able to do everything. Thank you.
Dayanduna. Make sure you do catch all these lessons. They happen Monday to Sundays. They're going to be back again tomorrow on the Sunday restorations with Mpoma Gwabeni just between 9 and 10, and also on the Just Drive between 5 and 6. Remember, this lesson was actually brought to you by Kagiso Radio Teacher. And man,